One of the things about streams that I have not emphasized yet that I definitely want to illustrate is that streams are in fact lazy. I've been producing streams and even infinite ones and just limiting them using the limit method. But in fact, when you do filters, when you do a map filter reduce operation, interestingly enough, the system will only process as many values of the stream as are required to satisfy the filter. I'm going to illustrate that during this section, but before I do that, let me just show you a couple other interesting features of streams. So here, for example, is a stream using a generate that's generating random numbers. I'm limiting it to 1,000 of them. One of the other methods in collectors is called summarizing, and there's summarizing int, summarizing long, and summarizing double. So I'm going to take those random numbers and extract the double value off of them, and then call summarizing double and print out the resulting double summary statistics. I could explain what that is, but frankly it's easier just to see it in action. So if I run this, look what I get. I get an object which has count, which tells you how many elements were produced. There's the sum of all the elements, there's the min, there's the average, and there's the max. And if I was to work with this double summary statistics class, there are methods for extracting all these individual pieces out of it, should I want to. So this is a really nice system. There's a double summary statistics, and there's others as well in a similar fashion. So I just wanted to show you that that exists. Now another thing I want to point out, which I have not mentioned, is that if you are accessing a variable defined outside of a lambda, you can access it if it is in scope, but you cannot modify it. The phrase they use in Java is that any variable that's accessed inside the lambda that was defined outside must either be final or, quote, effectively final. And by effectively final, what they mean is that the code can't change the value. As soon as you try to change the value, then you will get an error. Now, in this particular example, I want to take my list of strings and I want to produce a list that has only the strings with even lengths to it. And let me, before I do that example, demonstrate the problem with the effectively final example. So say I have a value called x and I set it to 2, and now I'm going to say inside here what I want to do is say that I'm going to take a collection and modify that value. So I will take, in fact what I'll do here is I'll do stream.of, and I'll put in my sorry, I got to import my stream class there, 314159. And if I then do dot for each, then this takes a consumer, meaning I could put in a lambda. Now I could just do what we've done before, which is to say, oh, I just want to double them, something like that. And actually, for each takes a consumer. So this actually would be a good argument for map, if you will. Map to that, and then in fact, now that I think about it, I can do map to double for that particular one and then print them out. For each system dot colon print line. And there I can print all the values one by one. Now, so far I haven't done anything that's going to be an issue. Let me comment out the rest for the moment, and then I'll bring that back in after I do that. So if I run this particular example, you see what I've wound up doing is printing out the doubles of all of those values. I guess I could here have done this as map to int, would have made the same, made just as much sense, and I wouldn't have had to worry about doubles. And then that works just fine. However, let's say that in this lambda, I'm going to modify x. Now, I didn't do anything with x in here now, but I want to. So what I'm going to do is I'm going to introduce some curly braces here. And that means I need a semicolon at the end. And I also need a return keyword because I've said that I'm going to return that. And once I introduce the braces, I need to do that. But what I'm going to do now, first of all, let's just prove that this still works. Yep, everything's still fine. Is if I try to say x++, then the code does not even compile. I can try to run, and it's just simply going to fail because it says local variables referenced from a lambda expression must be final or effectively final. That is not legal. Now, On the other hand, what I can do is I can use that value. So if I make it n times x, that's fine. I can access it, but I cannot modify it unless it's marked final or is effectively final. Now, with that in mind, here is an exception that is not a good one. This is something that is legal but not a good idea. Say my external variable is a collection of strings. Here's my list of strings, and what I want is a list of strings that have only the strings with even lengths in them. Well, first I produce a stream, and then I'll filter them for each string such that its length is length mod 2 equals 0. So now I'm getting only the even length strings, and then what I can do in the for each is that I can invoke the add method on ArrayList, on collection, and then thereby changing the collection. Now you see, you would think, well, wait a minute, I thought I could only access things that were final or effectively final. Well, when you say final on a reference, you mean the reference can't point to another object. It doesn't mean that the thing I'm pointing to can't change. So what I'm doing here is I'm leaving even lengths as a reference alone, but I'm modifying the array list that it's assigned to. That's a workaround, but it's not a good idea. This goes by the name side effect. This is a side effect inside the lambda, which means that running the lambda actually modifies things outside the scope of the lambda. And that's considered, at best, poor form. So how do we get around that problem? Well, that's why instead of doing a for each and appending to a collection, I've been using the collect method to produce a brand new list each time, and now there are no side effects. Nothing is defined as a local variable outside and then modified as I go along, neither the reference nor what the reference is assigned to. So that handles the whole side effect issue. Very important there. Now the next issue is about laziness. Now, here what I have is a main method where I'm trying to find the first even number that's divisible by 3 in the range between, actually the first, I shouldn't say first even, I should say first double divisible by 3 between 100 and 200. Let's fix this. So there is a method called range in int stream, which will produce all the values between 100 and 200. And then here I'm going to multiply each of them by 2. I put that as a separate method so that I could print out that I'm actually invoking it on a particular number and then doubling it. I filter it by only those values that are divisible by 3 and then find the first, which will return an optional. So I could say or else 999, which means that I didn't get anything. I could probably pick a better number for that, but regardless. Here's the interesting part, however. If you read this sequentially, it looks like I create a range of 100 numbers, or 101 numbers, from 100 to 200 inclusive. And then I multiply all of them by 2. So now I've got a new stream with all those numbers in them, 101 numbers. And then I filter them down to the ones divisible by 3, filtering all of them, and then find the first one, which seems like an awful lot of work to find the first value divisible by 3. Well, here's the cool part. By doing the print inside multiply by 2, when I do the double there, you're going to see that's not at all what happens. When I run this, you'll see it starts with 100. And then it multiplies by 2, and then it checks to see is that divisible by 3, and the answer is no, and therefore it does 101. And that's again not divisible by 3. They're the doubles, not divisible by 3. And then it goes 102, and it doubles that one. And is that divisible by 3? Yes, it is. So that's returned as fine first, and that's what's printed out at the end here. And you can see the laziness made it so that I did not waste all that time doubling and dividing by numbers that I didn't need. It worked through the overall stream and set up the process, and then did the process for each element of the stream until it found the one that satisfied the filters inside there. That's what they mean by laziness, and this is going to be a great benefit for processing, because we don't have to process an entire collection. We could just process a stream element by element and stopping when we're satisfied. So very nice there. Now the last thing I want to show you in this section is something about concurrency and parallelization. Here is a collections demo. I have a list of numbers, and I've put in the first 25 decimal places for pi. So starting at 3.141592653588979, etc., all the way out to here. Now what I want to do ultimately is I want to turn that collection into a stream. I want to map them somehow, and I'll show you what the map looks like in a minute. Mostly I just want to double them. And then convert it back to a list and print the list. So ultimately the goal of this is to print the doubles, if you will. Why write it separately? Well, here's the doubler function, and you see it's a simple lambda to do doubles, and that's what I'm calling here. But I also am going to have a doubler with a sleep inside it. So this takes the value n, and it sleeps for 100 milliseconds, and then returns the double. So same idea, except that I've got a sleep going on in there. So that when I use this function, the doubler with sleep inside of print nums, I expect this to take roughly 2.5 seconds. See, I've got 25 numbers. Each number is being processed sequentially. It's taking 100 milliseconds per number, so it's roughly 2.5 seconds. However, and this is one of the lessons of all this stuff, once you have something working with stream, you can try it with parallel stream and thereby automatically use all the processors on your disk simultaneously. Now, by default, when it uses parallel stream, it tries to spawn as many threads as you have processors. In my case, I've got 8 cores on this machine, so I should have 8 processors operating concurrently. Now, of course, what's necessary for this to be workable is that none of these numbers need to depend on each other. The doubling process only depends on the number I'm on. So doubling 3 has nothing to do with doubling 5 or doubling the 4 over here or anything, so that these things can all be done in parallel without a loss of generality. So what I've done is I say, let's instantiate this class, and I'm going to time each of these. I get the start time, I call the regular doubler, and get the end time, and print out how long it took. Now this one doesn't even have a sleep in it, so this ought to be really, really fast. When I call the same thing with the sleep in it, this is the one that ought to be roughly 2.5 seconds. And then I'm going to use the parallel one, the one that uses parallel stream, and see how long that takes. So when I run this, you could see there's my collection. And in the first one, the second one took 2.6 seconds, roughly 2.5 seconds. And then the third one took about 0.4 of a second, because it was able to do so many of these simultaneously. Now, I can make one change to this, which will slightly mess it up a little bit, but I just want to do it for an illustration at the moment, is that when I'm doing the doubler with sleep here, I can also print out, and I don't like doing prints during the middle of a lambda because it can mess up all kinds of parallelization mechanisms, but it is legal, is I can go thread.currentThread and find out which thread I happen to be on at the moment. I don't even think I need the get name, but I can print it if I like. And I'm only doing this in the doubler with sleep. So when I run again this time, the first one is right away, and you can see in the second one I used the main thread over and over and over again. Still took about 2.6 seconds. And then when I did them in parallel, you see there are all these different worker threads. That one plus main is 8 separate threads. So there are my 8 threads all being used throughout here, and each one that's being used is the one that happened to be done next as I go through all this. And again, it still only took about 0.4 seconds. So that's an illustration of some of the concurrency mechanisms inside of Java 8, because all I have to do is change stream to parallel stream and I'm in business. Now if I did something like stream.of, then there's a method called parallel that will then make it a parallel stream. Again, this is a rich area. There are a lot of interesting things to talk about and go on with, but this has already been a pretty extensive section. So I just wanted to leave you with that. So the ideas here again are that streams are lazy. They will only process as many values as are required, and they can be processed in parallel once the values are independent and don't depend on each other, so that the process can work effectively in parallel. Hopefully all that will be useful for you as well.